Howdy, this is your friendly neighborhood physics teacher here, and we're going to talk about power. There's actually not much to do with power. Okay, yep, powerful sneeze, woohoo! Anyway, so power is just how long something, pretty much, to show how powerful you are, is how much work you do over a certain amount of time. It's basically what power is. So our power equation, hello, please work. There we go. So our power equation that you see on your formula chart is your change in energy over time. But remember that also on your formula chart, that change in energy equals work. So our power is just our work over time. Now we think about relationships. We think about relationship-wise. As your amount of work goes up, as you increase work, and we're keeping time the same, as your work increases, your power is also going to increase. So that is a direct relationship. So that is a direct relationship. If we're looking at work over time, if we're looking at time, so as if we keep work the same and we increase time, so we're dividing by a bigger number, power is actually going to go down. So that is an inverse relationship. That is an inverse relationship. If we take it a step further, and we're looking at power is work divided by time. If we keep power the same, we're keeping power the same. So think about a lab, like I give you, like, okay, you've done 10 joules of work, and you did it for you did it for 2 seconds or 2 minutes, and so you have this much power. If you increase your work, what would you have to do to your time to keep power the same? You would actually have to increase your time too. So your work and time have a direct relationship. If you can't see it there, go ahead and manipulate the formula to solve for work. So work equals power times time. So again, if we keep power the same, as time increases, your work is going to increase. Just looking at it in the division version just kind of takes away a little thing. And I did it again. I didn't talk about any units or anything. So power is actually measured in watts. And then you have your energy, which is in joules, and you have your time, which is in seconds. So basically what watts means, watts is joules per second. That's a weird looking S. Let me try that again. Second. So watts is just joules per second. So a lot of people think about like, oh, I'm so powerful. And the best way is like you think about like if you're pumping iron. So you're not changing the mass, so you're not really changing the force that you're going against, because you're going against gravity. When you're pulling it up, you're going against gravity. And so the only thing you can modify is time. So the quicker you do it, so if you decrease your time, you're more powerful. Now, if it takes you a longer period of time to do it, you're not as powerful. You're still doing the same amount of work. So if you go walk a mile versus run a mile, burning the same amount of calories. It's just taking you the less time. It's basically the only, just short amount of time. So walking versus running, doing the same amount of work. Just from how powerful you are is how long it takes you to do it. It's kind of a weird thing to think about. So yeah, so power, that's power. Power is usually, on the AP test, is usually just like a little snippet. So not a big deal. If you have any questions, let me know. Have a wonderful day. Bye.